Welding is a process that joins materials, typically metals, by melting them together, often with the addition of a filler metal, and then allowing them to cool and solidify, creating a permanent bond. This process relies on heat and/or pressure to fuse the pieces, forming a single, continuous structure. Welding involves melting the base metals and, sometimes, a filler metal to create a molten pool. As the molten metal cools, it solidifies, forming a weld that is stronger and more durable than the original pieces. Various heat sources can be used, including electric arcs, flames, like in gas welding, or friction. Filler metals, like welding wire, are often added to help fill the gap between the pieces and improve the weld strength and properties. There are many different welding methods, each with its own advantages and disadvantages. Some common types include arc welding, including MIG/MAG and TIG, gas welding, and friction welding. Arc welding is a fusion welding process that uses an electric arc to generate heat, melting and joining metals. This process relies on a power source to create an arc between an electrode and the workpiece, melting the metal and forming a weld. Various types of arc welding exist, each with its own characteristics and applications. An electric arc, formed between the electrode and the workpiece, produces intense heat. The heat melts the metals at the joint, and sometimes a filler material is also introduced from a consumable electrode, creating a molten pool. As the molten metal cools and solidifies, it forms a strong bond between the pieces being welded. Arc welding is widely used in various industries, including construction, manufacturing, and shipbuilding. Arc welding is one of many fusion welding processes used to join metals. It uses an electric arc to create intense heat to melt and join metals. Gas welding, also known as oxy-fuel welding or oxyacetylene welding, is a welding process that utilizes a flame produced by burning fuel gases, like acetylene or gasoline, with oxygen to generate heat and melt metals for joining them together. It's a common technique used for various applications, including repair work, sheet metal fabrication, and joining aircraft parts. The heat necessary for melting and fusing the metals comes from a flame produced by mixing and burning fuel gas with oxygen. It's a type of fusion welding where the edges of the metals are melted together, often with the addition of a filler rod, to create a strong joint. Common applications include repair work, sheet metal fabrication, automotive chassis and frames, and joining aircraft parts. Gas welding equipment is relatively mobile, as it doesn't require electricity, it only relies on fuel gas tanks. In plain terms, gas welding is a method of joining steel by heating the surfaces to be joined to the melting point and allowing the two parts to fuse together with the addition of a filler rod where required. Normally, we think in terms of using a filler metal on all material 3/16 inch thick or more. All steel to be welded should be cleaned prior to welding so that it is free of oil, grease, rust, scale, or other impurities which may affect the weld quality or tensile strength of the finished weld. Generally, only oxyacetylene, in specific cases oxyhydrogen, is recommended for oxy-fuel welding. Resistance welding is a process of joining metals using heat generated by electrical resistance and pressure. It involves passing an electrical current through the metal pieces, which creates resistance and generates heat, causing them to melt at the point of contact and fuse together under pressure. Unlike some other welding methods, resistance welding doesn't require additional materials like filler rods or shielding gases. It's a rapid process, able to create welds in a fraction of a second. The heat and pressure cause the metals to melt and fuse, forming a strong, solid joint. Resistance welding is used in various industries for joining metal sheets and components, including manufacturing, automotive, and aerospace. Spot welding, seam welding, butt welding, and projection welding are all types of resistance welding. Some factors influencing heat or welding temperatures are the proportions of the workpieces, the metal coating or the lack of coating, the electrode materials, electrode geometry, electrode pressing force, electric current and length of welding time. Small pools of molten metal are formed at the point of most electrical resistance. To To ensure a safe welding process, welders should always wear appropriate personal protective equipment, PPE, like a welding helmet, gloves, and fire-resistant clothing. Good ventilation is also crucial to prevent the buildup of harmful fumes. Before starting work, inspect all equipment for damage and ensure the work area is free of flammable materials. Ensure adequate ventilation to prevent the accumulation of harmful fumes and gases, especially in confined spaces. Consider using fume extraction systems or local exhaust hoods if natural ventilation is insufficient. Inspect the work area for potential hazards before starting work. Read and understand the operating manual for the welding equipment. Take breaks to avoid fatigue. Ensure proper handling and storage of gas cylinders if used. Maintain a clean and organized workspace. Energy efficiency in welding involves optimizing processes and technologies to minimize energy consumption while maintaining weld quality. This can be achieved through various methods, including choosing energy-efficient welding processes, using advanced power sources like inverters, and employing techniques that reduce the amount of molten metal needed for welding. Welding has a wide range of applications, from structural engineering and manufacturing to repair and restoration. It's used in industries like construction, automotive, aerospace, and energy, joining metals and other materials to create durable and functional products. Welding automation uses equipment, software, and devices to automate welding tasks, offering benefits like increased efficiency, reduced costs, and improved safety. It can range from simple automated systems to fully automated robotic welding, depending on the specific needs and application.